Assalamu alaikum. Now we are going to start variation in pressure of static fluid. That is the mathematical part to calculate the variation in pressure for the altitude and for the atmosphere.
Now applying for the first condition of the vertical equilibrium, take a disk as taken previous of width dy. The force P plus dP into A is acting downward, and also the weight is acting downward, and equal and opposite force of PA is acting from the downside as the pressure is being exerted from the all sides. Now for the equilibrium condition, all the vertical forces should be equal to 0. For this, measure Fy should be equal to 0. Now adding all the forces, we have the downward force which is acting on the upward side, that is plus Pa into minus P plus dP into A plus the weight acting downward minus W is equal to 0. Now solving this equation to balance the equation, Pa minus Pa plus A dP minus W is equal to 0. From previous we got the value of W rho G A dy. Using this value we have cancelling Pa and Pa. Then we have the equation A dP minus rho G A dy is equal to 0. From this, A dP is equal to rho G cancelling A and A on the both side, we get dP is equal to minus rho G dy. From here, dP over dy is equal to minus rho G. The term minus rho G is called weight density. That is called weight density. Now we will take the elevation points. If P2 is the elevation point at Y2 and P1 is the elevation point at Y1, then integrating the both limits for this, we can have from the wave equation, the previous equation was dP over dy minus rho G. Then dP is equal to minus rho G dy. Integrating P1, P2, dP is equal to minus rho G y1, y2 dy. From here we get P2 minus P1 is equal to minus rho G y2 minus y1. Now taking P2 equal to the Earth atmospheric pressure, Earth atmospheric pressure, and P1 is equal to P at any level Y1 in the fluid, we get P naught minus P is equal to minus rho G H and P is equal to P naught plus rho G H. This relation shows that the pressure in the fluid increases with the depth, but the same as all points at the same depth. It means this variation is according to the depth. Now, for the variation of pressure in atmosphere, we can calculate as using the Boyle's law. As we can move from Earth's surface to the altitudes, the pressure decreases if the temperature is constant. Now, using the Boyle's law at the sea level, we have PV is equal to constant and density is given as rho is equal to mass per unit volume. Then using this equation in above, P m over rho, that is equal to constant as mass of fluid is constant, then P over rho is also constant. As P over rho is constant, here density of air is proportional to the pressure of the atmosphere of the earth. Now, this equation can also be written as P naught over rho naught is equal to constant. From here, we can compare equation 1 and 2. P over rho is equal to P naught over rho naught. From here, rho is equal to P rho naught over P naught. Now, relation for pressure and height is given as dP over dy is equal to minus rho g. Putting the value of rho in equation, dP over dy is equal to minus P rho naught over P naught into G, then dP over P is equal to minus rho naught over P naught G dy. Integrating this equation by applying the limits, by using the limits, P is equal to P naught at y is equal to 0 and P is equal to P at y altitude, then 0 P naught to P dP over P is equal to minus 0 to y rho naught over P naught G dy. We have log of P minus G rho naught over P naught into I. This will become P over P naught minus G rho naught Y over P naught. Use G rho naught over P naught is equal to 1 over A, then log of P over P naught is equal to minus Y over A. Solving this equation, we have 9.8 into 1.29 for the atmospheric pressure on the earth, 1.01 into 10 raised to power 5, we get 0.117 per kilometer. Here value of A is equal to 8.55 kilometer. Solving the equation for the natural log P over P naught minus Y over A. This gives P is equal to P naught exponential minus Y over A. This relation shows when we move above the sea level, pressure decreases exponentially. The atmospheric pressure is 0.1 atmosphere at altitude 20 km above the sea level. The atmospheric pressure is 0.01 atm at the altitude 40 km above the sea level. The atmospheric pressure reduces to zero at the infinite level from the sea level.